In episode 6 of Mobycast, we introduced part 1 of a technical series around the creation of containers. Specifically, Jon and Chris teach me about base images and volume mounts. Welcome to Mobycast, a weekly conversation about containerization, Docker, and modern software deployment. Let's jump right in.
What we're going to talk about today is we're going to go a little deeper, a little more technical. We're going to talk about containers themselves and how we have been setting them up. So we're going to talk about the Docker file and how we configure it, what we like to do, what features of Docker we make use of, because there are about 1.3 billion features of Docker, and I think we use a solid 15. And I want to talk about at least a few of those and why we don't, what makes our Docker setup work well for us. So to get started, I think the first thing that makes sense, and this was a good idea that Rich had, is instead of just jumping right in and saying, well, this is our Docker file and this is how we set it up, we should probably say the different, we use containers in different ways. And so maybe Chris, you can tell us a little bit about how we use containers.
Sure. So containers, you can run them anywhere, the full spectrum of your pipeline, ranging from running on your local dev machine for just kind of doing the dev test integrate cycle, through automated testing on your test platforms, and then of course actually using containers for deploying your services. And so companies, teams, they can use any mix of that, and it kind of just dives into the what are the features, the benefits that you're looking for, what are the missing pieces to kind of dictate what part you may adopt. So maybe the important takeaway here is that you don't have to use Docker through all those phases. Sometimes it might make sense where you really are looking for this feature of getting away from, well, it works on my machine, right? And having ways for maybe your product managers to be able to actually bring up the latest code base themselves on their development on their laptop or something like that. So running Docker locally might make sense, but you already have maybe a rich system in place for doing CI, and you have a different way of doing deployment, and you may not want to do that.
So I'm hearing you say that we run containers on our dev machines to do development and to do local testing. I think you also said that we run containers in staging or on a test machine or in production. Would it be fair for me to say that in each of those different scenarios, or you could call them container use cases, is it always that our containers are configured to run exactly the same way? Or would we have a situation where we've actually built our containers differently to fit the use case that we're running it in?
Absolutely. How you configure and orchestrate your containers will definitely be different depending on your use case. So what we've talked about this before in previous episodes, where one of the major benefits of containers is that they're isolated, right? They're basically an island. It's a hermetically sealed environment for your application, if you will, right? Where it really doesn't know about or it knows very little about the outside world, and vice versa. And there's some great benefits to that for just as far as just security, for kind of decoupling and having just running many of these things on the same machine, all thinking that it's only them that's there. So, but that kind of one of the first things that developers will run into is, wow, this is super difficult to deal with, right? Because now, in order for me to, maybe I'm outputting logs to standard out and standard error. And so before I would just see it on my command line when I ran my code. Now, when if I'm running under Docker, well, that's actually inside the Docker container. And so now I have to do something different, right? I may shell into the Docker container like I would shell into a remote machine. And that gets to be, kind of, okay, this is different. And this is kind of feels like a hurdle. There's other hurdles in that process as well, especially with the hot reloading, right? So especially if you're doing things this is really a painful part of the process if you are Dockerizing like a client application, like you're writing React code or Java's front end JavaScript code, and you want to go change even like a div tag or something like that. The first thing out of the box would be like, wait a minute, I have to rebuild my Docker image to see that one little change. This is really, really painful. So definitely in the development environment, there's ways to to alleviate this pain. And so you end up kind of punching some holes into that isolated container to allow these kind of like these use cases to make it more developer friendly. That said, you need to know what repercussions that may have, and we can talk a bit more about that as we go through this. But there are some trade-offs to that, because you're now giving up some of the great features of Docker in exchange for better productivity for your developer.
Right, and you're getting into exactly what I wanted to start to get into. So we're dealing with setting up our containers. We set it up in the way that Google or Stack Overflow said would work, and we start developing, and we're hating life. So one of the first features of Docker that we use is this ability to punch holes into the container so that we can stop hating life well, maybe we'd love life, right? Maybe all of a sudden, now that we have to wait a minute and a half between each div change, we get to binge a show on Netflix. But really, we've lost our productivity. So let's talk about how do you punch holes into the container, and how do you make sure that you only do that in dev? Because it does sound sort of dangerous to do that anywhere but dev.
Yeah, absolutely. So, one of the more common ways to do that is through volume mounts. And so what you're doing is that you're now volume mounts in with Docker allow your container to share data with its host. So remember, all containers require a host system on which to run, on which the Docker daemon is running and spinning up your Docker container processes. So you always have a host computer, and so that's typically, like, if you're running locally on your machine, that's your MacBook is going to be your host computer, and so the local drive on your MacBook would be the host file system. When you spin up your container, you can say, hey, I want to have a volume mount, and I'm going to map a path in the container, a file system path inside the container, to map to a file system path on my host. So that means now whenever I read or write from the file system inside the container, it's actually reading and writing from the same location on the host system path. So volume mounts are definitely one of the core techniques here for doing this. And it's not even just for necessarily hot reloading or developer productivity. It's also for things like just insight into what's going on. So like a really great use case for this would be log files. So your application almost certainly is generating log files to indicate what's going on in the system and diagnostics, and when warnings are happening or errors are happening. You can punch this hole in the container to say, hey, write these log files out to my host system, so that I can now see, as a developer, I can tail those log files inside my command line. I don't actually have to go inside the container to see it, and they can also persist across sessions. So volume mounts are definitely one of the core techniques here.
So with volume mounts, this gets really, really confusing to me, because, okay, so now our logs are all of a sudden it almost feels like we're developing on our local machine again, where we're making hot deploys and all of our logs are coming into a place where we don't have to SSH into a host container to see them. So I can be developing, I'm a developer. I'm working away. I've been working away 3 or 4 hours. I've maybe even done 3 or 4 features during that time. How do I know when it's time to do a build for real? Because at this point, it's like I'm not even really using the container anymore. The container is just sort of running the code, but I'm doing the code on my local machine. When does the developer know when to stop doing the hot deploy stuff and start and make a build?
Yeah, so it's a great question. We could probably talk a little bit about what's the harm, right? Okay, we have this volume system mount. So and let's talk about the hot reloading portion of this. So as a developer, I want to make some tweaks have that automatically get picked up. My code's running inside of a Docker container, have that be reflected instantly so that now on the screen I can see what happened without doing a Docker image rebuild. So my volume mount is basically sharing the same directory, the same file path as where the actual source code is. And so now I can edit the source code on my host machine. Because that is now shared via volume mount with my container, the container, you set that up, your process running inside your container to have hot reloading for a file system watcher, so that when changes happen in the file system, it just knows, hey, I'm gonna recompile, right, with Bobble, or I'm gonna restart Node or something like that, whatever the case may be. And those changes immediately happen. And so even though it's still running inside the container, I now see the differences. So that sounds pretty good. The downside to this is, you're sharing quite a bit of the host system. So the surface area is pretty broad, right? It's basically your whole source code tree. And the big danger here is, what if you now have artifacts, pieces of code, various files that perhaps aren't checked into your source repo? They're only on that one local machine, such that, hey, it works fine on my machine. And so you're running inside this container that's sharing this volume system mount for your for kind of ease of development. You run your test, everything's working great. And so you check it in you push it to the remote repo and source code, and you're like, hey, job well done. Someone else on your team does a pull, they run it, and immediately it's broken, right? It doesn't work. And that's because there were specific files only on your machine that you forgot to check in. You didn't know that because your container had access to those files outside of its process space. And so that's the downside of doing this. So the way you kind of get around this is you do a hybrid, right? So you can, using like Docker Compose, you can set up multiple different containers. And one of the things we like to do is you'll have one container that is for when you're doing this dev iteration process, right? And so you call that like my app-dev or something like that. So you have to be a bit more mindful that you're running the dev version of it. And that particular definition would have the volume system out defined.
Chris, let me stop you for a second. You just introduced something called Docker Compose. My understanding is that Docker Compose will let me create multiple Docker files, and each Docker file defines my container.
So Docker Compose is a tool that allows you to run multiple containers and you can have those as kind of like as a cohesive unit. And you don't have to run all of them. You can pick and choose which ones you want to run. But it's just a way of it's a way of like automating the command line for Docker of like starting, stopping services and whatnot. Docker Compose is like a kind of like this value-added surface, a wrapper on top of that stuff. And it allows you to easily define how these containers should be started, how they should be configured. That type of thing.
That's the part that I'm kind of confused on. So in order to, we're punching a hole in the file system or in the container by using these volume mounts. And I think that that's the thing that you have to do in your Docker file. You have to say, Docker file, punch a hole for me, please. And is Docker Compose, is that creating one version of the Docker file that uses volume mounts and another version of a Docker file that doesn't? Or is it doing it some sort of other way?
So that volume mount is actually defined outside the image. So you could do it by hand. Yeah, you could do it by hand, right? So you could say, so when you do a Docker run command, you would specify as a command line flag to that saying like, here's the volume mount I want to have for this container. Likewise, you would specify, like if you're using Docker Compose, inside your Compose file, you would say, okay, here's the container I'm defining, here's its name, here's the image, the Docker image it should use. Oh, and here's the volume mounts. You can have more than one volume mount too, right? So it's done above and beyond the image. It's part of its runtime environment.
Why did I think that you do volume mounts inside the Docker file? Maybe you can do them in there too if you know that that's what you want every time.
Well, what you're doing inside the Docker, maybe what's confusing is you have two different locations, right? You have the Docker file has to know when it builds a Docker image, it has to know, about the host file system as well as the eventual container file system, right? Mm-hmm. So you're basically you're defining how that container should look when it does get instantiated from the Docker image. And so there's two different file system spaces when you're dealing with it, because you're basically saying like, hey, my source files are coming from my host, and so that has one path, and then I want to write them inside the image, and that's a different path, right? Mm-hmm. And so in a way, you kind of have already this volume mount, if you will, when you're building Docker images, but that's just for building the bits. And remember, Docker is totally portable, right? So we would never bake in like a file system mount, because there's no guarantee that path would even exist on whatever host you ran that image on, right?
Right.
So it has to be defined. It has to be specified at runtime on whether you want that or not.
Okay, cool. Yeah. That's a good explanation. Thanks. So I forgot where we were.
I think so. We were kind of saying like, hey, during the development mode, you would have one way of configuring your container. So you would say, when I'm in development mode, I'm going to run my Docker container with this file system mount, right? And I'm going to iterate and test and everything. But before I actually commit my changes to my source code repo, I have to run it in that non-promiscuous mode, right? I have to now run my container without the volume system mount and verify that it's working. And that is also the mode in which your build machine or your CI machine is running its test, right? So you have these other safeguards in place along the way to make sure that you are indeed building a clean, pure image.
So then going back to my original question of when a developer would do that, they would probably do it when they would normally do it, whenever they feel like they're ready to ship to the rest of the team.
Exactly. When they're ready to commit to the remote repo. And then, of course, if they didn't do that, right, and then your Circle CI machine, your CI machine runs its test, it breaks the build, then everyone knows it's like, John didn't do it. He didn't, John was lazy. He didn't run test. He didn't do it the right way.
Right. Okay. So now we know about being able to do these volume mounts to be able to either do hot deploys or get your logs without having to shell into your running container. I think another topic that covers like how do we make our containers is just what do we start with? You can start with just a plain old Unix machine with nothing on it, or you can start with some containers that already have stuff on it, like a database or maybe they have Nginx or some other thing. So how do we decide what to start with?
Absolutely, yeah. So it's another a great question and a kind of an area with lots of discussion around it. So yeah, when you're building a Docker image, one of the first things you have to decide is like, what's my base image? What am I starting from? And so, typically you need to start with like, just at the very least, like what operating system, like what flavor of an operating system are you starting with? And the choice of where to start kind of ends up, you have to take into, various factors, things like, okay, ease of use, like what packages are installed and how much I have to maintain versus like how much someone else is maintaining. So you can think of it as like, how much are you bringing in? You can go with a very, very small base image, which means the surface area is much smaller, which gives you perhaps much better performance, stability, and definitely security. But the trade-off is like now you have to do a lot more yourself on that. So you may have to do a bunch of additional steps to install the necessary software that you need. Like maybe you need a compiler, and you now have to kind of build that into your Docker image yourself manually, right? So you have to define that out. Versus, you can start with an image that someone else has made. Like you said, it may be specifically for like Python, or it may be for running Postgres or something like that. And you can start with that kind of image. But again, the trade-off is just you're bringing it. Your surface area is so much more increased. There's so much more software running inside that base image that now you're opening yourself to more security vulnerabilities. You have the issue of like, am I up to date with the latest? Like, what am I actually pulling in? And it also puts more onus on you to really understand like when you derive from that base image, you have to go like understand like what is that base image doing, and so there's some responsibility there. Just as if you were to pull in any other piece of like open source code, if you go use get some module from npm or a Ruby gem or something like that, like it's your responsibility to know like what's in that code, and so kind of the same issues come into play with base images.
So you said something that I'm not sure I agree with, because let me just try to say why. You talked about the surface area being smaller or bigger depending on your base image. At the end of the day, if you need, let's call it, you need Python on there. At the end of the day, whether Python was pre-installed or whether you compile and install it on a Docker image that didn't have it, you still end up with a container that has Python on it. So what is the difference? Security-wise, I wouldn't imagine there is one.
Well, if that was the only difference, then sure, it's not. But realize when you maybe the Python image that you took is based on the Jessie Debian distribution, and that not only has Python like support for it, but it also has maybe the Java JVM on it, and it has maybe some networking services that you really shouldn't have installed on there, right? So that's where it kind of comes into play, where you have to go look to see what is it that you're inheriting from what base image you're using.
Got it. So if you choose a base image that somebody else made somewhere else, it could be trustworthy, but it comes with whatever it comes with. And if it's got stuff you don't need on it, that's probably a no-no for production.
Yeah,
especially
absolutely.
For sensitive systems.
Can I jump in with a question or two?
Sure. Go ahead, Rich.
So you have a new client, and it's a new product. And so you're not inheriting a legacy product. You're building it from scratch, and you've gone through the strategy sessions and you start to think through how you're going to build this. Do you guys, as Kelsus, a team, start with even just bullet pointing what the base image needs to be, and is that how you start that project, by building a base image from which all the developers will use, or do you sort of like evolve that image over time as the complexity of it increases? I know that you're probably always going to have to evolve it, but I always think of like the efficiency of, does Kelsus just have like a base image that they use for most of their projects, or at least do they start all of their projects with this idea of how a base image might look, or are you always sort of like doing that alongside at the same time of development?
So that process is definitely evolving, and it kind of depends too on the project itself and whether it's kind of an existing client where we have more of a track record. We know exactly what the requirements are and like what the environment should look like versus a new one. So one of our bigger clients with multiple projects on it, we've definitely gone to this route of having a common base image that we use across all these, because it ends up being like we're very much a Node.js shop on the back end, Postgres, usually for backing stores, and then moving towards React for our front end clients. So pretty common tech stack across that. And so we have kind of, and we also have some common shared code libraries that we use across those projects, right? That are kind of specific to that particular client. So we definitely have gone towards having like a standard base image for that kind of includes that general setup and config for that type of environment.
Is that base image one that we grab from somewhere, or is it one that we're maintaining?
Right. It's definitely one that we're maintaining, right? So there's some benefits there. So you can, you definitely can speed up your builds, right? By like identifying what parts are kind of common that you don't want to keep repeating over and over and over for every single one of the projects. So if you know that you're going to be doing like a, npm install of like these 10 common modules that pull in these other dependencies, and every project is going to use that. It's just kind of, it knows that those underlying services are there. Then why have like all 10 projects do that over and over themselves, instead having one common image that's kind of baked into it, and have those projects inherit off that so that they don't have to do that work. So it speeds that up. It makes the Docker files definitely more modular. But the trade-off is you now have to maintain that base. You're maintaining the base image, right? So you need to update that periodically, and then likewise need to make sure that everyone that's inheriting off that base image, that they're picking up the new updates. So not, if they're locked into a specific version number or tag, then they need to change that. So there's some additional maintenance there, but a lot of benefits with it.
Oh, sorry, Rich. I just wanted to take a shot at a rule of thumb. Because to me, it feels like the biggest trade-off is maintaining your base image and all the things that might be on it versus waiting for containers to build. Because you can always build images with whatever you want on them. And waiting for when I say waiting for containers to build, the benefit is you're always up to date. So during the dev process, you can say, just always grab the latest of everything so that I never fall behind. So that seems to be the trade-off. And it feels to me like a good rule of thumb is, if the stuff that's on the container is sort of heavy to build, time-consuming stuff. So I'm talking about things like ImageMagick, which takes forever, or Nginx takes forever to build. Those are multi-minute builds. I think ImageMagick may take like 10 minutes on a compute. On a full big beefy computer. I don't know how much it would take on a sort of stripped down container. So if you're sitting around waiting for 25 minutes for containers to get created, that's going to start to create bottlenecks in your CI/CD pipeline, right?
Absolutely.
Right. So that trade-off has to be just right, where as much as you can get built on the fly without waiting forever, it seems like you should just have it get built by the container. Then you're always up to date. You have less surface area to maintain. But anything that's sort of hard, that takes a long time, probably should build it in. Probably should just bite the bullet and know that every once in a while I got to go check and see if there's a new ImageMagick or a new, whatever else it is that you're maintaining on there, right?
Mm-hmm. Yeah, and paradoxically, there's actually some advantages sometimes to not being completely up to date.
Oh, sure.
Right? So this is actually like one of the arguments for having like a common base image where it is locked in, because you can test and this is especially true like in the land of Node, where NPM, you have NPM modules that you're getting from the open source community. Those are changing all the time. People are supposed to follow semver, but they don't have to, and some of those authors don't even understand semver. And so you may find that by saying, "Hey, I want the latest minor version," it actually breaks my code. Right. You didn't do anything, right? It was no code was checked in at all, no changes were made, but just by virtue of doing a new build, it's now broken and it doesn't work. And so sometimes kind of locking yourself in with a base image on certain things like that, there's some advantages to it.
I just really want to drive that point home, because I had a startup at one point, and it was a Ruby on Rails startup, and gems just change all the time. They're just constantly in flux. And we had a developer who's kind of the lead developer, who sort of insisted on always being up to date, because he never wanted to, deal with the pain of getting too far behind and the amount of churn that could cause. But this is one of those startups where we were working in our spare time, and eventually I was just like, dude, you have to stop doing this, because every time you sit down to code, you spend your first hour and a half fixing all the broken stuff that came from the gem update. Stop. Like, let's let them sit for a while. Yeah. Rich, I'm sorry we cut you off a little bit ago. Is your question still there? Is it still?
Yeah, it's more of like a practicality question. So I imagine, much like Git, your repo, the remote repo that houses these base images, they can be forked too, right? So you could have a base image that is really just a starting point for projects, and then you could fork it and then create it specific for that project. Is that true?
And by I'm sorry, so you're saying as far as like starting with someone else's base image, forking it, and that becomes yours? Was that your question?
Yeah, I mean, is it similar to the way that your open source code in Git would live, where if I like it, I can just fork it and Git as a starting point?
Absolutely. In that, what you could do is, so Docker images, they get you refer to specific Docker images basically by like their repo name as well as like a tag, right? And there are ways to kind of say, like, hey, I want to, you can reuse the same tag, and like a common convention is latest, right? So you can say, I'm going to go get, my base image : latest. And then that way, whenever I build, theoretically, I'm getting whatever the current version of that Docker image is. Conversely, you can lock it into a very specific tag. So you can say, I only want 2.6.2. And so if you lock it into a certain tag like that, your base image, then you can absolutely think of that as a fork, right? So if you say, I'm going to create my own base image, it's based on this other third-party image. I'm going to lock it in to a certain version number, so to a certain tag. At that point, I have effectively forked it. And now, it's not going to, it should, unless they republish under that tag, right? Which they could do. But, in general, like that would be expectation would be that they wouldn't. You can also...
Chris, it sounds like there's kind of three things if you do that. There's the original base image, its tag. Then there's going to be some code that you have in GitHub that says, here's how to make the image that I want from my original image, because it's going to install some stuff onto that original image. Mm-hmm. And then there's the artifact that it creates that then gets put back into Docker Hub or EMR, ECR, Elastic Container Registry, as the new, your new tagged base image, right?
Mm-hmm. Yeah. And so like you can actually further protect yourself from what I was just talking about there, where if the original base image, if they republish with the same tag, almost all of these Docker images that you would use as base images, you can see the actual Docker file that was used to create that. And so you could fork that, right? So you could go and fork the actual Docker image, the Docker file for that image, and then build it yourself.
That's what I meant, is that, it's my code and I can change the Docker file, but it at least has, I don't know, however many lines of code already done for me. And now I can add to it or remove from based on the project.
Yeah. Yeah. So almost, like I said, almost all these is definitely all the open source ones, the ones that are in public repos, these Docker images that are in public repos, they will publish the Docker file, and you can build it from the actual Docker file instead of grabbing it from the repo that they publish to.
Right on. So I think that, just given how technical today's conversation has been so far, we've talked about volume mounts, we've talked about base images. I think that may be enough. I think that my head is already spinning with all this stuff. We had thought about talking about, okay, now we have containers and they may need to talk to one another, and how do you deal with that? But that sounds like maybe something we should talk about next week.
Oh man, John, I am just getting started. We got so much more to talk about. I could keep you guys here for hours. So no, seriously, I agree. I think that's a lot to cover today. It definitely was a bit of a deep dive, I think, and plenty of stuff to talk about in future episodes.
Great. Well, thank you for joining us today. It's been a fun experience.
Great. Thanks, guys.
Later. Well, dear listener, you made it to the end. We appreciate your time and invite you to continue the conversation with us online. This episode, along with show notes and other valuable resources, is available at mobycast.fm/06. If you have any questions or additional insights, we encourage you to leave us a comment there. Thank you, and we'll see you again next week.